Hello. Hello, good evening. Is it audible?
Yes, sir.
Yes, sir.
Okay. Whether the skin is visible?
Yes, sir.
Yes, sir.
Okay, man. So in the last class, we discussed about these Maxwell equations, about the different fields like time varying field, static fields, and free space mediums. So these magnetic fields you can deriving from the Gauss laws. Okay, Gauss law of electrostatic, Gauss law of electromagnetics, and Faraday's laws, and the last one is Ampere's laws. Okay, so I can recall once again. Now we will do some problems based on these Maxwell equations. I think today some of the triple E students also joined for this session. Okay, so Gauss law for time varying field del dot d is equals to rho v. This is nothing but in terms of time domain or differential forms, whereas in the integral form, integral of d into d of s is equals to integral of rho v into d of v. That is nothing but surface integral is equals to the volume integrals. Okay, that is nothing but the Gauss law of electrostatic, whereas in Gauss law of magnetostatics, del dot b is equals to 0. Therefore, integral of b into d of s is equals to 0. Now, this Gauss law of electrostatic and magnetostatics defined based on the dot product. Okay, whereas other two laws are defining based on the cross product. Okay, that is the cross product del dot del cross E and del cross H. Now, first we will see del cross E is equals to minus dou E by dou T. Okay, this is the Faraday's laws of electromagnetic induction. And another formula is del cross H is equals to J plus dou D by dou T, where J is the current density. Okay, that is equals to, in terms of integral form, integral of H into D of L is equals to integral of J plus dou D by dou T into D of S. This is nothing but the line integrals, integral H into D of L. This is nothing but the line integrals is equals to the surface integrals. Okay, so the cross product is defining in terms of line integrals to surface integrals, whereas the dot products defining surface integrals to the volume integrals. Okay, now this is for while considering the time varying fields. Okay, now in terms of static, that is whether it is a constant, then del cross E is equals to 0. See previous case, del cross E is equals to dou E by dou T, that is the rate of change of electric field intensity with respect to the time for time vary, whereas in static it is a constant, therefore the differentiation is equals to 0. Okay. Similarly, del cross H is equals to J plus dou D by dou T. Dou D by dou T is equals to constant. So it may that there is no rate of change of field density. That is dou D by dou T. That is equals to 0. Then it will comes only del cross H is equals to J. Okay, so this is nothing but a modified Ampere's law. Similarly, del dot D is equals to rho V, that is same similar to the time varying field, and del dot B is equals to 0. This is also similar to the time varying field. Whereas in free space medium, okay, now these two are defining based on the different mediums, like a conducting medium or dielectric mediums. Whereas in the free space medium, the Maxwell equations for time varying field in free space medium, that is the atmospheric mediums, then del cross E is equals to minus of dou B by dou T. Okay. Similarly, in terms of integrals, you can take the integrals on both sides. Then integral of E into D of L is equals to minus of dou by dou T into B into D of S. Okay. Similarly, del cross H is equals to, the previous equation is del cross H is equals to J plus dou D by dou T. But there is no current density because it is in the free space mediums. Okay. Now, similarly, del dot D is equals to 0 and del dot B is equals to 0 in terms of Gauss. and Ampere's and Faraday's laws. Okay, now so you can write all these formulas, then you can go for some problems based on these Maxwell equations. That problems is collected from the previous question papers. Okay, so once again you can write down these expressions, all of you. Write fast. Once you are completed, you can tell me. I will go for next slide. Do fast. So is it completed? This slide. Hello. Hello. Is it completed now? So next one. Again, please respond. Whether it's completed or not.
Completed, sir.
Okay. What about this one? Time varying field in free space. So completed. Ma, please unmute, ma. Students, please unmute your mic. Students, please mute. I think 401 Radhika. Radhika, mute your mic. Radhika,
Sir.
mute your mic.
So, sorry, sir.
Okay. Okay, next. Now, we'll do some problems. So all of you can take paper and pen. Now I can see the first question. Integral of A into D of L is equals to integral of C into D of S. Integral of A into D of L is equals to integral of dash into D of S. What is the answer? I think there is no options here. Integral of A into D of L is equals to integral of, that is line integrals is equals to surface integrals. So what is the name of this theorem? Line integral is equals to surface integrals. So anyone tell me what theorem it will convert the line integrals into surface integrals? Anyone? So integrals of A into D of L, this C is nothing but the closed loop, that is this closed loop. Okay, so integral of, that is closed integrals, A into D of L is equals to closed integral of dash D of S. So what is the name of this theorem? So on what theorem this line integral is equals to the surface integrals? Okay, that is nothing but the Stokes theorem. Okay, now integral of A into D of L is equals to del cross A into D of S. Using the Stokes theorem, that is line integrals can convert into the surface integral. This A dot D of L is equals to del cross A into D of S. Okay, so here in that line you can fill it del cross A based on the Stokes theorem. Okay, next second question. The electric field strength at a distance of point P due to a point charge plus Q located at the origin is 100 microvolts per meter. If the point charge is now enclosed by a perfectly conducting metal sheet sphere whose center is at the origin, then the electric field strength at the point P outside the sphere becomes dash. Tell me what is the answer? The electric field strength at a distant point is P due to a point charge plus Q located at the origin is 100 microvolts per meter. If the point charge is now enclosed by a perfectly conducting metal sheet sphere whose center is at the origin, then the electric field strength is E at that point outside the sphere becomes dash. See the question. Now you can take one point charges is Q located at a point origin. Then from this point to, suppose this is a point. Now this is the Q. Okay, this point. Now this point to distant point is some P. Distant point is P. Then due to the point charge plus Q located at the origin is 100 microvolts per meter. If the point charges is enclosed by a perfect dielectric metal sheet sphere whose center is at the origin. Okay, now this is the spherical coordinate. X, Y, and Z. Okay, now, so what they are asking is the field strength outside the point of, this is the spherical coordinate at a point of P. Then what is the electric field outside this sphere is equals to what? Here the electric field is 100 microvolts per meter. Hundred microvolts per meter. Okay, then what is the electric field intensity outside this sphere is equals to what? So anyone? So what is the answer here? Whether it is 0 or minus 100 microvolts per meter, or same electric field 100 volts per meter or 50 microvolts per meter. What is that value? So what is the value? Is it audible? Hello? Is it audible? Please respond, anyone?
Yes, sir.
Okay. So what is the answer here? See, if the charges is Q is at the origin, the electric field intensity is 100 microvolts per meter. These charges is distributed for this entire sphere at a distant point is P. If the electric field intensity outside this sphere, then there is no electric field intensity. Okay, because of this electric field of a charge Q is The strength is only within this sphere. Outside this sphere, the electric field intensity strength is equals to 0. Okay, therefore the answer is 0. See, the point charge will induce a charge Q on the surface of the metal sheet of the sphere. Using Gauss law, the net electric flux passing through the closed surface is equals to charge enclosed. Okay, so that is equals to D is equals to 0, epsilon is equals to 0, because D is equals to epsilon into E. Okay, so E is equals to 0. Already we know the formula, D is equals to epsilon into E. Then the electric field strength is equals to 0 outside this loop, outside the sphere. Okay, so therefore D is equals to epsilon into E. Okay, so the E value is equals to 0 outside this sphere of the metal surface. Therefore, D is also equals to 0. Okay, therefore the answer is 0. Okay, now next question. The Maxwell equation del cross H is equals to J plus dou D by dou T is based on what? Now tell me this equation. Del cross H is equals to J plus dou D by dou T. So what is this law? This is the direct question from the Maxwell equations. Del cross H is equals to J plus dou D by dou T. The magnetic field intensity is in terms of electric fields. And sometimes this equation, this dou D by dou T, also you can write down in terms of electric fields. Okay, this equation dou D by dou T, also you can write down epsilon into dou E by dou T. Okay, dou E by dou T. You can write down that anyway. Because of D is equals to epsilon into T, epsilon into E. That's why sometimes they will ask J plus epsilon into dou E by dou T. Both are same. So which equation? Whether it is the Ampere's law or Faraday's law or Gauss law or Coulomb's law?
Ampere's law.
Ampere's law. Any others? Others, please respond. Okay. So the option is Ampere's law. Okay. So the Maxwell equation del cross H is equals to J plus dou D by dou T. Whereas in Faraday's laws is defined based on the electric field del cross E is equals to dou B by dou T. Okay. Like Gauss law is del dot D is equals to rho V for electric fields. Whereas in Gauss law in magnetic induction del dot B is equals to 0. Okay, so there is no Gauss law. Gauss law is defined based on the dot product, and Faraday's law is defining del cross E is equals to dou B by dou T, and Coulomb's law F is equals to, that is force between the two charges. F is directly proportional to the product of the charges Q1 and Q2, and inversely proportional to the distances, that is d square. So F is directly proportional to Q1 Q2 divided by R square. That directly proportional, you can remove it and write down some constant. That constant is 1 by 4 pi. Okay, that is the Coulomb's law. Okay, so that given equation is not a Coulomb's, is not a Faraday's, and it is not a Coulomb's Gauss law. So it is a Ampere's law. Now I can see the next question. Next. So what is the unit of del cross H is dash? The unit of del cross H is equals to dash. ampere, ampere per meter square, ampere per meter, ampere meter. So what is the unit of del cross H? Tell me what is the unit of del cross H? So what is the unit del cross H? Anyone? Now the answer is amperes per meters square. Now see why it is amperes per meter square means, see, generally B is equals to mu H. Is it? B is equals to mu H. Okay. Therefore H is equals to B by mu, where mu is a constant value and this B is the magnetic flux or magnetic lines of force. That flux is per unit cross sectional area. Okay. So the actual magnetic field within the material considered as a concentration of magnetic field lines or flux per unit cross-sectional areas. So the flux produced by these any materials is the per unit cross-sectional areas. So that's why you can consider per unit cross-sectional area, that is meter square. So the total del cross H is equals to amperes per meter squares. Okay, answer is C. Okay, next. Now, del cross P, where P is a vector, is equals to dash. Del cross P, where P is a vector, is equals to dash. Here we can apply the curl. Okay, where del is the divergence, del P, gradient, divergence, and curl. If it is del dot P, then that is called, while applying any gradient with any vectors P with a gradient operator delta with a dot product, then that is called as a divergence. That is nothing but we can represent in del dot B. If the any gradient delta of any vector P applying the cross product, that is del cross P, then that is called as a curl. Okay. Now here it is del cross P. Curl of a curl of P, where P is a vector. So the gradient operator delta applied of a vector P in cross product, that is del cross P, again applying the cross product, that is del cross P is equals to what? So what is the answer? You can apply for distributive law. Already we discussed in the first class. Commutative law, distributive law of vectors and scalars. So what is the distributive law? Either in the summation or in the product. Suppose in terms of summation, A into B plus C is equals to AB plus AC. So A into B plus C is equals to, or A cross B plus C is equals to A cross B plus A cross C. Okay. In terms of product, A cross B cross C is equals to what? The same formula I can apply here. Anyone? Whether you know or not, please respond. Don't waste of time. You know or not?
D, sir.
What? What, man?
D,
Option
sir.
D, sir.
D. What is the answer? What's the answer?
Option D, sir.
Option D. Any others? Any others? Yes. Okay. So del cross P is equals to del into del dot P minus del square P. Okay. Simply you can apply the distributive law. Del cross P is equals to del into del dot P minus del square P. Okay. That is option is D. Very good. Next. Now see what is this one. If a C is a closed curve enclosing a surface S, then the magnetic field intensity H, the current density is J, and electric flux density is D, or related by. So this is similar to the Maxwell equation in integral forms. This one is the direct question from the Maxwell equation. Integral of, see the first option, double integrals of, that is surface integral. Surface integral is representing with double integrals. Line integrals is representing with a single integral. And the surface integral is representing with two integrations, and the volume is representing with three integrals. Okay, so first option, double integral of h into d of s is equals to integrals of, that C is nothing but the closed loop, integral of j plus dou d by dou t into d of L. And second option, double integrals of s into h of d of L is equals to integrals of j plus dou d by dou t into d of s. Third option, similar, integrals of h into d of s is equals to j plus dou d by dou t into d of L. And third one is h into d of L is equals to j plus dou d by dou t into d of s. See the Ampere's law in Maxwell equations. Del cross h is equals to j plus dou d by dou t in terms of integral forms. So which one is coincide that equation? So what is the answer? See the Maxwell equations. Yeah. Second one. Integral of h into d of L is equals to integrals of dou d by dou t plus, otherwise you can take for the electrostatic, this one, time variable. Del cross h is equals to, now see, integral of h into d of L with line integrals is equals to the surface integrals. So line integral is equals to surface integrals. So this equation is similar to, in which option of this? So what is the answer here? So line integrals is equals to the surface integrals according to Stokes theorem.
D, sir.
Answer is D. Why it is not equal to B? B is also same, no?
Surface integral. Oh, line integral, sir.
Yes. Okay. See the B is also surface integrals of h into d of L is equals to the closed surface of j plus dou d by dou t into d of s. Okay. This one is mistake. So the answer is closed loop integrals of h into d of L is equals to surface integral of j plus dou d by dou t into d of s. So the answer is D. So for the time varying field, the Ampere's law relating to h, j and d is given by del cross h is equals to j plus dou d by dou t in terms of spatial domain, whereas in the frequency domain or integral forms by applying the Stokes theorem. So del cross H is, you can apply in the Stokes theorem, that is equals to H into D of L is equals to double integrals of del cross H into D of S, that is equals to del cross H is equals to, you can substitute in this value here. Okay, so integrals of J plus dou D by dou D into D of S. So the option is D. Next. Now, for electric, static, electric, and magnetic fields in an homogeneous source-free medium, which of the following represents the correct form of two Maxwell equations? See the question: static, electro, and magnetic fields, not for the free space medium and not for the time-varying fields. Static, electric, and magnetic fields. So, which equations is correct for static and Maxwell equations in static? First one is del dot D E is equals to 0 and del cross B is equals to 0. Second one is del dot E and del dot B, both are equal to 0. And third one, cross product del cross E and del cross B is equals to 0. And fourth one, del cross E is equals to 0 and del dot B is equals to 0. So which one is correct? So we are expecting
D,
minimum, yeah, we are expecting minimum 2 to 3 bits in Maxwell equations. What Which question? What is the answer here? To 550. It is not just. So what is the answer?
D, sir.
Why it is equal? Why it is D? Why it is D? What about A, B, C? Hello?
Faraday's law and Gauss law.
Faraday's laws and Gauss law.
Gauss law, sir.
Okay. See the first bit, first option A, del dot E is equals to 0. But in static field, del dot D is equals to rho V. Is it right? Is it? Del dot D is equals to rho V. D is equals to E into epsilon, whatever may be. So del dot E is equals to rho V by epsilon. So that is wrong. And in that same way, del cross B is equals to 0, but del cross B is not equal to 0. Cross product of magnetic field is not equal to 0. Only del dot B is equals to 0. So option A is wrong. And B is del dot E is equal to 0. That is wrong because of del dot D is equals to rho V. That is also wrong. Then third option C, del cross E is equals to 0 and del cross B is equals to 0. So del cross B is equals to 0. That is wrong. So the other option is only del cross E is equals to 0 and del dot B is equals to 0. So the option is D. Now see all the Maxwell equations, del cross H is equals to J plus dou D by dou T, and del cross E is equals to minus dou D by dou T. Then del dot B is equals to rho, and del dot B is equals to 0, or 4 equations. Now, while applying the static electric fields and magnetic fields, first one, del cross H is equals to J, because of dou D by dou T is not equal to Z. This is 0. Okay. Next, del cross C is equals to, this one is 0, second term. For static, this term is equals to 0, it will come del cross H is equals to J, and del cross E is equals to minus dou D by dou T. For static, this term is also equals to 0, so it will comes del cross E is equals to 0, and del dot D is equals to rho, and del dot B is equals to 0. Therefore, this equation and this equation is this one, D. Del cross C is equals to 0, and del dot B is equals to 0. Next, what about this one? The divergence of a vector field A is equals to x into A of x plus y into A of y plus z into A of z is dash. So what is the answer? The divergence, that is del dot A. You can apply in the gradient of a vector A. So what is the answer? First option is 0, second option is 1, third option is, sorry, second option is 1 by 3, third option is 1, fourth option is 3. So what is the answer? So the divergence of a vector field A. So divergence is del is equals to dou by dou x plus dou by dou y plus dou by dou z. Okay. Now del dot A. Okay. So del dot A is equals to, so first of all, del is equals to dou by dou x plus dou by dou y plus dou by dou z. Now del dot A, because the divergence of a vector is nothing but, you can apply the dot product of a gradient of any vector A is equals to dou by dou x into A of x plus dou by dou y into A of y plus dou by dou z into A of z. Now, while applying the del dot A, then x into A of x, that is equals to, it will comes 1, because A dot B is equal, A dot A is equals to B dot B plus C dot C is equals to 1. Okay, so that according to properties of the dot product, then A dot A is equals to 1. Okay, whereas suppose A dot cross A is equals to, what is the value? Well, the cross product of any vector by itself is equals to 0. Okay, suppose any vectors A, B, C, then A dot A is equals to B dot B is equals to C dot C is equals to 1. Whereas in cross product, A cross B is equals to C bar, B cross C is equals to A bar, and C cross A bar is equals to B bar. That is, it will comes cycle, that is the clockwise directions. Okay, A, B, C. So A cross B is equals to C bar, B cross C is equals to A bar, C cross A is equals to B bar. Okay, but in the dot product, the any vector by dot product of that vector itself, that is equals to 1. So while applying the dot product of this one, dou x by dou x is equals to 1, plus dou by dou y is equals to dou y by dou y is equals to 1, because while applying the differentiation of these entire equations, these two terms is equals to 0, only it will comes dou x by dou y. While applying the differentiation with respect to y, x and z is 0. Similarly, dou y by dou y is equals to 1. So while applying the dot product of this entire equation, now x and y is 0, then it will comes only dou z by dou z. So this is equals to 1, plus this is equals to 1, and this is equals to 1. So 1 plus 1 plus 1 is equals to 3. So the answer is D. Okay. So see. Yeah. So del dot A is equals to, so A is equals to for the given problem, then del dot A is equals to dou by dou x, dou y, dou k, dou z is into x is, A is this one. Okay, so dou by dou x, dou by dou y, dou z by dou z. Okay, and the remaining terms is you are differentiating with respect to x, and y and z is constant, whereas differentiating with respect to y in the center terms. For this one, differentiating with respect to x, other terms is 0. Here, differentiating with respect to y, other terms is 0. That is, x and z is constant. Whereas differentiating with respect to z, then x and y is constant. Okay, so similarly, we're differentiating for this equation dou by dou x, that is equals to 1, dou y by dou y 1, dou z by dou z 1. So 1 plus 3 is equals to 3. Based on the product, that is I dot I, j dot j, k dot k is equals to 1. Okay, next I will go for next topic, that is plane electromagnetic waves. Okay, okay, next one. Now suppose assume that, now we'll see the, yeah, now see the diagrams x y z directions. In that x y directions, there are three coordinates. The electric field is in one direction, and magnetic field is in other directions, and the waves are propagating in some other directions. Okay. Now here, the y direction is in the electric field, and the z direction is in the magnetic field, and the x direction is the waves is propagating with a velocity of c in x directions. That is the meaning. Now see here, the electric field is in y directions, generally x, y, z. Okay, so while the electromagnetic waves are propagating in the free space medium, Okay, that is electromagnetic waves. It will comes electric field as well as the magnetic field. That electric magnetic waves are representing in three-dimensional coordinates, that is x, y, z directions. In the x direction is the electric field, and y direction, sorry, y direction is in the electric field. You can take any direction. Suppose if it is x, y, and z directions, whatever may be. Okay, here you can consider y direction is the electric field and z direction is the magnetic field, and the x direction is the waves is propagating the electromagnetic waves in the x direction in the free space medium with a velocity of c. Okay, so what is the velocity of c? So c is the velocity of light. So what is the value of velocity of light in free space medium?
Three.
What more? What is the value of velocity of light? 3 into 10 power 8 meters per seconds. That is the light velocity or velocity of light. Okay, 3 into 10 power 8 meters per seconds. Okay, so the electromagnetic waves also propagating in the free space medium, that is equals to the velocity of light. Okay, now assume that the point P, the magnitudes of E and B of the fields depends on X and T only, but not depends on Y or Z coordinates. A collection of such waves from the individual source is called as the electromagnetic waves. Okay, now surface connecting points of equal phase in all the waves, call it as a wavefront. Now, while propagating the electromagnetic waves in this free space medium with a velocity of light c, then all the waves have the same phase and the same magnitude. If the phases are same, if the phase does not change while propagating the waves in the free space medium, that is called as a wavefront. Okay? A surface connecting points of equal phases in the sphere. For this situation, that is called as a spherical waves. Okay? In this direction, while the waves is propagating in the sphere, then that is called as a spherical waves. Okay. The following differential equations relating to E and B, for simplicity we can neglecting the subscripts, whether it is x direction or y direction or z directions. Dou E by dou x is equals to dou B by dou t. This is from the Maxwell equations. Okay, that is electric field is equals to the magnetic field, that is equals to, now these electric and magnetic fields are propagating the x direction with a velocity of light. That value is you can derive from this mu naught and epsilon naught, where this c is equals to 1 by mu naught into epsilon naught. That is this one, where c is equals to 1 by mu naught into epsilon naught, where mu naught is nothing but permeability, okay, absolute, and epsilon naught is absolute permittivity. Generally mu is equals to mu of r into mu naught, whereas epsilon is equals to epsilon r into epsilon naught. Here relative permeability is equals to 0, that is not considered because it is a free space medium, that is equals to 1. Only you can consider relative permittivity and a relative permeability. Okay, now you can substituting this mu naught and epsilon naught value, then you can getting the velocity of light is c. Okay, mu naught is equals to 4 pi into 10 to the power of minus 1, and epsilon naught is equals to 1 by 36 into 10 to the power of minus 9. Now you can substituting these two values, then you can getting the c value, that is equals to 3 into 10 power 8 meters per seconds. Okay, now, while the waves is propagating in the vacuum, dielectric medium and free space medium, there are different planes. So in terms of vacuum, E of Z is equals to E of Y is equals to, or E of Z is equals to whatever may be the directions. Okay? So E of Y is equals to E of Y of Z into E power j omega tau. Okay. Next one. In vacuum, the phase velocity of the waves equals to the velocity of light. So the phase velocity. So what is that phase velocity? That we'll see later. Okay. In a vacuum, the phase velocity of the waves equals to the velocity of light. Now, what is the wave number? So wave number k is equals to omega by c, where omega is equals to 2 pi f by c, then f by c is equals to, sorry, c by f is equals to lambda. Okay, so lambda is equals to c by f. Therefore, 2 pi by lambda. This 2 pi by lambda is equals to, we can call it as a beta. That is the phase constant. Okay. Since the waves are propagating in vacuum, the phase velocity of these traveling waves are V of phi is equals to plus or minus omega by k, where omega is equals to radiation frequency, radiance, that is 2 pi f, and k is equals to wave number, that is equals to plus or minus c. So already we told that the phase velocity is equals to the velocity of light while the waves are propagating in the vacuums. So in general, the phase velocity is a vector since it has both the magnitude and directions. It has a value greater than the light speed. However, there is no energy or particles transferred at that speed. Okay. So in general, the phase velocity is a vector. It is not a scalar. So phase velocity is a vector. It has both magnitude and directions. But this value is greater than the velocity of light. But there is no energy. Okay. Now, so is it audible now? Is it audible? Hello.
Yes, sir.
Okay. Now, next, characteristics impedance of the mediums. Now, Z is equals to omega mu by k. Okay. So that k is omega is equals to k into c. See in the previous expression here k is equals to omega by c, where omega is equals to k into c. The same expression I can recall here. So omega is equals to k into c. Okay, so k cancel, then it will come c into mu. So mu into c is equals to 1 by mu naught into epsilon naught, that already we know. So welcome. This mu is also, you can write down square root of mu into square root of mu. So one square root cancels, then it will come square root of mu by epsilon. Now you can substituting this mu value and epsilon value, then the characteristics impedance of the medium, it will come 377 ohms. That is the free space impedance, or 125. This is the, so therefore Z is equals to, this mu is equals to, you can write a mu naught into mu of r, epsilon is equals to epsilon naught into epsilon r, where epsilon r is equals to 1 and mu of r is equals to 1, because the relative permittivity of the free space medium is equals to 1. Therefore, you can substitute in this mu naught and epsilon naught value, that is equals to 125. So pi is equal to 3.167 something value, then it will come 377.73 ohms. This is the characteristics impedance of the free space medium. So the impedance value in the free space medium, that is in the atmospheric, the resistance is 376.73 ohms. Next are reflections. So reflection and refractions. So reflection means when the waves is abrupt changes, okay, while propagating the waves from one medium to the another mediums. That is in the boundary conditions. Okay, suppose you can see here, this is the incident waves. the waves is coming here, and due to this is the air medium and water medium. Here we can consider two mediums, air medium and water medium. When the wave is from crossing the boundary of the air medium to the water medium, well, it touching and return back with an angle of reflection, then that is called as a reflected waves. Okay. Whereas when the incident waves is propagating from one medium to the another medium, it is crossing the boundaries from one medium to the another medium, then that is called as a refraction with some angle. Directly it won't comes here. It will be comes some angle. When we putting the sticks on a glass of water, then while showing that sticks in front of the glass, then that sticks will show like it is bending because of the sticks is comes from the air medium to the water mediums. Okay, but in the reflection means it will be written back with an angle. Okay, so reflection and refractions. Okay? Reflection is the abrupt change in the direction of propagation of the wave that strikes the boundary between the different mediums. Okay? Whereas refraction is the changes in the direction of the waves passing from one medium to the another medium. So while crossing the boundaries from one medium to another medium, the speed must be changed. The speed is changes. Okay? While the waves is refractions. These are the things can be used in while propagating the waves in the free space medium from antenna to the from ground station to the satellites. The waves is bending due to because the waves is propagating with the different layers in the atmosphere. That is stratosphere, ionospheres, okay, tropospheres, in all the waves, in all the while the waves is propagating from ground station to the satellites, the waves is penetrating with the different layers, tropospheric layer, ionospheric layer, stratospheric layers, and all these things. Okay? So each time while the waves is crossing from one layer to another layer, it will be bending, crossing. Okay, and the last one is polarization. Polarization is the property of electromagnetic waves such as light that describes the direction of the transverse electric fields. Okay, so polarization is the property of electromagnetic waves such as light that describes the direction of the transverse electric fields. Now, this polarization is describes the direction of oscillations in the plane perpendicular to the direction of travels. So, in which direction the waves is propagating? Okay. So, based on this propagation of the waves, the polarizations are divided into linear polarization, elliptical polarization, and circular polarizations. When the waves is propagating in linear, then that is called as a linear polarization. When the waves is propagating in the direction of propagating in the circular, then it is called as a circular polarization. The waves are propagating in the elliptical shape, then we can call it as the elliptical polarizations. Now, so I can recall this phase velocity. I already told that the phase velocity is equals to omega by k, where k is equals to wave numbers, and omega is the radiance in frequency, that is 2 pi f. Whereas in group velocity is the rate of changes of this omega, dou omega by dou k. Here it is the amplitude it changes the shape of the wave amplitude while propagating the waves in the free space. That velocity v of g is equals to dou omega by dou k. Okay? But the phase velocity is more than the velocity of light. Okay, that is the phase velocity and group velocity. So phase velocity, the rate of changes of phase when the waves is propagating in the space, whereas in group velocity, the rate of changes of amplitude while the waves is propagating in the free space mediums. That is the group velocity. So that is the topics. Okay. So any other doubts? Any other doubts? So in this one, so first part is over. First two parts, that is Maxwell equations, is over. Plane waves, reflection, refraction, polarizations, phase and group velocities. Okay. So now I will close the session. So any doubts? Okay. Thank you. Now I can leave the class.